Good afternoon. My name is Uma Maheshwari. I am here to discuss about the topic of gate primitives and gate delays in the unit of specification using Verilog HTL. Here in this Verilog structure primitives, like gate level, this is the programming based one, like digital electronics, like one output boolean operators, that is AND, OR, XOR, NAND, NOR and XNOR. Like AND means we will be giving two inputs and we will be getting the output as 1. That is, if both the input are 0 and 0, the output will be 0, and inputs are 0 and 1 means 0 into 1, that is AND is for multiplication. So we will be getting the answer it as 0, and was 1 and 0 the output will be 0, and 1 and 1 means the output will be 1. In the case of OR gate, here it is for addition. So if there is any 0 and 0 as the input we are just giving, and we will be getting the answer as 0, and 0 and 1, the combination of input means we will be getting the output as 1, and 1 and 1 means we will be getting the sum as 1 and the carry is 1. XOR is nothing but that is also a 2 input and then 1 output gate. And NAND is nothing but your AND gate, but we are just adding NOT in that, so that is called as NAND gate. And NOR is also OR gate, just adding the NOT gate in this. And here the example is C is equal to A comma B. Here we have to declare the variable as a C comma A comma B, means we will be declaring 3 variables over here, that is one is C and one is A and one is B. Here in this one the output is C and A and B both are input, so A and B. Example, C is equal to A plus B plus D, or we can have this C comma A comma B comma D. One input operators, that is not 1. In this one, like A is equal to not Z. So example is A is equal to not Z. So here in this not of A comma Z, A is the output, so we have to write it as the first term, and Z is the variable which we are going to use in this operation. So the next two example is example A is equal to not Z, B is equal to not Z. Here in this not of A comma B comma Z, but if but it's like not, but just replicate the signals, we don't need the transistor level primitives too. We will be not using this module circuit with delay, that is A comma B comma C, X and Y. Here we are just declaring this input as A comma B comma C and the output as X comma Y, and the wire is E, that is wire means that is the connection part, and hash 30 of G1 of E comma A comma B, or 20 of G3 of X comma E comma Y, that is X and Y is the output, we have to connect that. So for that connection we need E. This E is nothing but your wire. Here the NOT gate we will be using. In the previous slide itself we have seen that like only one input is needed for that NOT gate. So we are just using a G2 of Y comma C. Here in this the Y is the output and C is the wire, that is the input we are just giving. Delay means the time duration between assignment from RHS to LHS. All continuous assignment statements which executes concurrently in order of the statement which does not impact the design. Here the data flow modeling. Here the delay can be introduced in like this: the associate time unit with physical time. Time scale is time unit per time precision. The example is time scale is 1 nanosecond per 100 second, and here the time scale is equal to 1 ns divided by 100 ps. Here this one time unit is equal to 1 ns, the time precision is 100 ps, that is 0.1 nanosecond. Here the 10.512 nanosecond is interrupted as 10.5 ns, that is nanoseconds. To specify the amount of delay from the input to the output of the gates, the delay is specified in terms of time units and the symbol hashtag. The association of the time unit with physical time is made using timescale compiler directive. The compiler directive starts with the backcode symbol. The time scale 1 second is 1 ns divided by 100 ps. The first number specifies the unit of measurement for time delay. The second number specifies the precision of which the delay are rounded off, in this case to 0.1 nanosecond. Here the module circuit with delay and half adder is, module circuit with delay is A, B, C, X, Y. The input is A, B, C and the output is X, Y. The same thing we have seen in the 2 slides back, and the end module we have to do it, otherwise the program will be thinking like some more continuation will be there in this one. So end module is the thing which is ends the, that is which is quit the program. This is the wavefront form of configuration half adder, and with the delay and without delay and behavioral modeling. In this behavioral modeling, assignment delay we are just checking this assignment delays and all. And the description styles is, this one is structural. Logic is described in terms of Verilog gate primitives, examples not and then or. The delay specification in primitives is also in this video. Delay and time scales, and delay in the smallest precision of all the time scale determines the time unit of the simulation, and user defined primitives and UDP table symbols, user defined primitives, UDP definitions and all. This continuation of this definition. The assessment is what is Verilog structural primitives and how the delay is calculated in this program flow, how user defined primitives calculated. Thank you.